Okay, so far we have been doing area that's above the x-axis, right? What happens when now we are considering areas that are below the x-axis? What will happen? Okay, it actually will become negative. Yeah, so you can go and try. If I were to integrate, for example, okay, because you know your sine function looks like this, right? What happened to my pencil? Spoil. Okay, you all know that your sine function is like this, right? And then from pi to 2 pi, it is below the x-axis. So when I take the integral from pi to 2 pi of the sine function, okay, let's do it very quickly. What is the integral of sine? Negative cosine. Okay, and then this will be negative cosine 2 pi minus negative cosine pi. So, negative cosine 2 pi, what is it? What is cosine 2 pi? 1. And then cosine pi? Negative 1. Okay, cosine pi is negative 1. Okay, y'all don't know, never mind. So this will give you negative 2. Can you see that? So when you integrate area that is below the x-axis, your area will become negative. But area can be negative or not? Doesn't make sense, right? Area cannot be negative. So what do? That's why we always take a, yeah, it's actually called the modulus, but modulus is of your syllabus. So we'll just take the negative, of the negative value to make it positive. Okay? So if I want to find the area of this, okay, it's actually called the modulus lah, this one. You actually draw 2 lines like that, right? But we removed that already from the syllabus, so it will just be take the negative value. So just put one negative sign in front, okay, to make it positive. So if you put a negative sign in front of everybody, you will get a positive 2. Okay? So there you get an area already, oh. Can ah? So this is what we call taking the absolute value. So that's what this paragraph is trying to say. Can you see the extra negative sign there? Okay? Are we okay? So let's look at example 9. Okay, I will just guide y'all, then y'all have to do at home already because time's almost up. Okay, the graph shows part of the curve. This is a cubic curve. The x-coordinate of the point P is given by 3 over 4. So this is 3 over 4. And then the x-coordinate of point Q is negative 2. Find the total area of the shaded area bounded by the curve, the x-axis, the lines from P and Q and perpendicular to x-axis. Now, if you were to do this, okay, I'm just gonna get y'all to go home and do this. Then you'll explain to me in tomorrow's lesson why it doesn't work. Yes, tomorrow got lesson. Okay, so if I just take the shortcut, I just integrate from negative 2 to 3 over 4. Okay, versus I split it up. Integrating from negative 2 to 0. Okay, that means the part above the x-axis. Then I add to, because the part below the x-axis I know is going to be negative. So I'm going to take a negative of that from 0 to 3 over 4. Okay, so there are 2 ways. I want you to explore these 2 methods and tell me which is the correct one. Can? So what if I integrate directly from negative 2 to 3 over 4? What will happen versus separately integrating them and then adding them together? Okay, try. So you go home and try this and then we will discuss tomorrow. You all got the answers, right? Did I print the answers for you all? Oh no, no, I missed out the answer for this one. Okay, I give you the answer. The answer is 10.0, rounded off to 3SF. Okay, the actual answer is 10.0 units, rounded off to 3SF. So, obviously, only one of them will give you 10.0. Okay, but I want you to try both. Then you will be able to understand and appreciate this formula a little bit more. Alright? Okay, we will continue this.